Hi everyone, welcome back. In this lecture, we are going to understand the different types of inheritance in Python. So first, let's recap what exactly inheritance is. Inheritance in Python is a concept where a class, known as a child class, can derive attributes and methods from another class called the parent class. This allows you to reuse code, reduce duplication, and build a clean object-oriented structure. There are 5 main types of inheritance in Python. We'll go through each one with a clear definition and then a detailed explanation based on the diagram. Let's begin. First, single inheritance. Single inheritance is the most basic form. It means there is one parent class and one child class. The child inherits everything from that one parent. In the diagram you can see this clearly. At the top we have a parent class named person, and just below it one arrow points to a child class named student. This arrow represents inheritance. The student class inherits all the behavior like name, age or display method from the person class. The child class can either use those inherited methods as is or override them and add new features. This type is simple and useful when we just need to specialize one base class. Now let's talk about multiple inheritance. This means a single child class inherits from more than one parent class. So 2 or more base classes but only one child. Look at the diagram now. On the left we have one parent class called person. On the right we have another parent called athlete, and at the bottom we see a single child class named student with arrows coming in from both parents. This means the student class is getting features from both, from person and from athlete. Maybe person provides name and ID, and athlete provides skills and stamina. The student class now combines both, becoming a more powerful class. This is useful when your object needs traits from multiple unrelated sources. But be careful. Multiple inheritance also introduces complexity, especially when both parent classes have methods with the same name. That's where method resolution order becomes important, and we'll learn about that separately. Next, multi-level inheritance. Multi-level inheritance creates a chain. One class inherits from another, and then another class inherits from that child, and so on. Imagine it like a family tree where traits are passed down across generations. Now check the diagram. At the top we have the parent class, person. Below that we see child class 1, student, which inherits from person. Then one more level below we have child class 2, graduate student, which inherits from student. This creates a chain: person, student, graduate student. So graduate student inherits everything from both student and person directly or indirectly. This is useful when your object evolves over time. For example, person gives basic info, student adds academic data, and graduate student adds degree specialization. Next, hierarchical inheritance. This is where multiple child classes inherit from a single parent class. So imagine one parent and many children. Look at the diagram now. At the top we have a parent class, person. Below that we have child class 1, student, and child class 2, teacher. Both arrows point up to the same person class. This means both student and teacher share the same basic structure from person, like name, ID, and contact. But then they specialize. Student adds grade and subjects, while teacher adds department and salary. This is extremely common in real-world software systems where different roles share a common base. Next, hybrid inheritance. This is the most complex type, and it's called hybrid inheritance. Hybrid means it's a mix, a combination of 2 or more types of inheritance working together. So hybrid inheritance combines multiple inheritance types such as multi-level or multiple inheritance to model more complex relationships. Now observe the diagram. On the left we have parent class 1, person and its child, employee. On the right we have parent class 2, athlete and its child, student. And finally, the employee and student classes are somehow connected. Either one inherits from the other or they work together through another class. This creates a blend of multiple hierarchical and multi-level inheritance, all within one structure. Hybrid inheritance gives you maximum flexibility, but also requires careful planning to avoid method clashes and confusion. It's used in complex systems where different modules are combined into a single class. Let's now quickly summarize what we've learned. Single inheritance, one parent, one child. Multiple inheritance, one child, multiple parents. Multi-level inheritance, a chain, grandparent to parent, parent to child. Hierarchical inheritance, one parent, many children. Hybrid inheritance, a combination of all the above. In the next lesson, we'll implement each type one by one using code examples. Thanks for watching. See you in the next one.